Good morning, students. Today I will discuss about the topics superposition principle of electrostatic force. Superposition principle of electrostatic force. So here, actually, at first I draw here one things. Here one point where Q1 plus Q1 charge is placed. Another charge is here minus Q2, another charge plus Q5, another charge plus Q3. Okay, sorry, minus Q3 is placed here, another charge plus Q4 is placed here. So in this diagram we can say the different charge particles are there in a particular way. Q1, Q2, Q3, Q4, Q1, Q2, Q3, Q4, Q5, different charges are there in this diagram. Now we know that when two or more than two charges are placed in a space, at first if I discuss about this is one charge particle and this is another charge. So if this two charge particle is placed here, in between them one electrostatic force will act, that we already have defined by the Coulomb's law of electrostatics. So when two charges are placed, then the force, electrostatic force, will act between them. But here when multiple charges are placed, then what will be happened? So here at first when Q1 charge is placed here, Q1 charge is placed here, Q2 charge, Q3 charge, Q4 charge, Q5 charge is placed here. So if we discuss about that only with respect to the Q1, this Q1 will feel a force due to Q2, due to Q4, due to Q3, due to Q5, all of them. So if the Q1 charge feel a force, electrostatic force due to all of this charge, then what will be the resultant charge acting on Q1? That is defined by the superposition principle of electrostatics. Here I see that here Q1 and this is Q4. If I discuss about these two charge, Q1 and Q4, therefore this is also positive, this is also positive. So here the force will be the repulsive force. That's why the F14, this is the repulsive force in between Q1 and Q4, and as it is repulsive, that's why I directed that direction. Similarly, if I say about Q1 and Q3, this is positive charge, this is negative charge. As these charges are opposite to each other, that's why the force will be attractive, that's why the force between them F13 directed along this direction. Q5, Q1, both are positive, so force will be repulsive, F15 directed along this direction, opposite direction, repulsive force. And simultaneously that Q2 and Q1, the opposite charge, attractive force along this direction. Now question is, then what will be the total resultant force? What will be the resultant force acting on this Q1? According to the superposition principle of electrostatics, the total force or resultant force that is on Q1, vector F is equal to the algebraic sum F12 plus F13 plus F14 plus F15. So here the resultant force on Q1, that is F is equal to some, that is F12 plus F13 plus F14 plus F15. That is the vector sum of all the forces. So this principle is known as the superposition principle of electrostatics. Write it down. So what is the total statement of this? Statement you can write: if different numbers of charged particles are placed in a particular space, then the resultant force on a particular charged particle is equal to the vector sum of all the forces, on this charge due to the other charged particles. F is the resultant force, is the vector sum of F12, F13, F14, F15. So this is the superposition principle of electrostatics. Write it down. Now one thing, just this already discussed in vector form of Coulomb's law. Again I repeat one thing. This is the three-dimensional coordinate system where Q1 and Q2 are placed, where the position vector of Q1 is R1 and position vector of Q2 is R2, and the distance between the Q1 and Q2, the position vector of that is R12. So if you apply the triangle law of vector addition, then we know that R12 is equal to R2 vector minus R1 vector. This was already discussed in the previous class. Now F12 is equal to the Coulomb's law. If you apply the Coulomb's law, F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R2 minus R1 modulus of R2 minus R1 square and R12 cap. This is the vector form of Coulomb's law, where R12 cap is the unit vector of R12 and R12 is equal to, we know that vector is equal to the magnitude into the unit vector. This is the representation of R12. So from this you can write R12 cap is equal to vector R12 by modulus of R12, vector R12 by modulus of R12. So R cap is equal to vector R12 and modulus of R12 means what? R2 minus R1, because you know that R12 means R2 minus R1, so R2 minus R1 mod. Clear is it? Cap of R12 is equal to vector R12 by modulus of R12 means R2 minus R1 mod. Now if we put this in this equation, then we'll put this in this equation. Okay? So here you can write F12 is equal to 1 by 4 pi epsilon naught Q1 Q2, it is R2 minus R1. R12 cap means vector R12 by this one, put this value, vector R12 by R2 minus R1. Clear is it? Is it visible? I think it's visible. Now, from here you can write F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 what's called there this. So square into this one is cube now. So you can write here R2 minus R1 cube, and there is R12 vector. R12 vector means you can write what? R2 minus R1. So R2 minus R1. So this is the vector form of Coulomb's law. Already we have discussed about it previous class. Again today I repeat because this will be used for the superposition principle. So F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 R2 minus R1 modulus whole cube, then R2 vector minus R1 vector. This is the vector form of Coulomb's law. Now if we apply this rule for the superposition principle of electrostatics, then what will be the resultant force? Now see here we draw the multiple charge. Listen very carefully. At first, see this. Here Q1 charge, Q2 charge, and several numbers of charge. Last time put that Qn charge. Qn charge. What is the position vector of Q1? R1. Position vector of Q3? R3. Position vector of Q2? R2. Position vector of Qn? Rn. Okay. Qn is Rn. Q2 is R2 is the position vector of Q2. Now just previously discussed, if Q1 and Q2, these two has the position vector R1 and R2 respectively. So from the vectors form of Coulomb's law, we can write F12 vector is equal to 1 by 4 pi epsilon naught Q1 Q2 R2 minus R1 vector, then R2 minus R1 modulus of cube. This is the force between the Q1 and Q2. Next is F13. F13 is the force between Q1 and Q3. So similarly, we can write Q13 is equal to 1 by 4 pi epsilon naught Q1 Q3, then R3 minus R1 vector and R3 minus R1 modulus of cube. This is the force between Q1 and Q3. This is the force vector from the Coulomb's law. And at last, this F1n, that is the force between Q1 and the Qn. 1 by 4 pi epsilon naught Q1 Qn Rn minus R1 cube modulus of cube Rn minus R1 vector. So this force is applied on Q1 due to Q2. This force is applied on Q1 due to Q3. This force is applied on Q1 due to Qn. Here we assume the different numbers of charges are there in this space. So if we want to discuss about the resultant force on this charge, resultant force